Hi, let us proceed with our example question. In the previous videos, we talked about the critical load arrangement for different columns of a key plan. We found that depending on the layout of the key plan, the critical load arrangement for each column differs. For that, ultimately, the columns shall be subjected to different types of loads, either uni-axial loads or biaxial loads. A column may be subjected to bending in the major axis, or minor axis, or both axes. In order to prevent the columns to be under design, normally we will go for the critical load arrangement under the principles giving priority to the bending moment. The critical load arrangement will play around with the maximum and the minimum loads with the intentions to generate the largest possible moment acting onto the columns that you are designing. Under that setting, the rest of the loads shall be taken as the maximum load. With that, you should be able to obtain the largest moment, and under the setting of the largest moment, you get the largest possible axial load. Since we talk about the maximum and the minimum load, as for these questions, you will need to determine the magnitude of the maximum and the minimum loads, so that you can proceed with the analysis in order to determine the moment and the axial loads acting onto the column. First, let us talk about the principles of the maximum load and the minimum load. We are talking about the ultimate limit state. That means there will be a factor of safety of 1.35 and 1.5 for GKs and QKs. The maximum load will have both GK and QKs present. That means that particular part of the structure is serving at its full capacity. Whereas the minimum loads, you will have only GKs without QK. That means that particular part of the building is totally vacant. The GK will always be there. As long as the building is in service, those loads shall be permanent. With that said, now we will need to determine the UDL for the frame B1 to 4. Referring to the key plan, this is the key plan for the ground floor and the roof floor, whereas this is the key plan for the first floor. The elevations of frame B1 to 4 is given here. Assuming that you need to design this column or any column within the frame here, in order to get the critical load arrangement, you're going to play around with the maximum and the minimum loads. Based on the GKs and QKs given in the questions, the maximum and minimum loads for the ground floor and the first floor will be the same, but the roof floor will be different. Therefore, we will need to calculate them separately towards the end until we acquire the maximum and minimum loads for the ground floor, first floor, and the roof floor. We are calculating the UDL acting onto the beams of the frame B1 to 4. The distributions of the load, it will be subjected to the aspect ratios of the slabs. It seems that all the slabs surrounding the frame B1 to 4 are one-way slab. Why is it so? You look at the Ly per Lx ratio. The Ly per Lx ratio is more than 2.0. That gives you one-way slab. And then how do you know the directions of the distributions? Is it in these directions or is it in these directions? For a typical one-way slab, you will need to imagine the most possible ways that the slab shall be bending. It is more likely to bend in these directions than in these directions. Now, if you have difficulty to imagine this, you can simply draw a 45-degree straight line from each corners. From here, you can imagine the directions of the bending. When the aspect ratios of Ly per Lx is relatively large, it will be as if the triangle will be relatively small as compared to the trapezoid. It is as if this triangle area is negligible, leading to the bending towards the shorter span. Based on the directions of bending, you know that the distributions of the load shall go in this manner. Having this understood, let us now calculate the GK and QKs acting on each floor. We are calculating the ground floor, first floor, and the roof floor. There are two slabs adjacent to the frame. Taking the ground floor as an example, we have slab AB and slab BC. That gives you slab AB and slab BC. For each slab, there will be GK and QK. Now we need to calculate the UDL. Taking the slab of the ground floor, slab AB, which is this slab. In order to get the UDL acting onto the beam here, you will need the GK and QK, which is represented in the mode of kilonewton per meter square in square areas. Whatever GK and QK obtained here, you're going to multiply with the Lx divided by 2, assuming that half of the weight will go to this side. This gives you the calculation steps. The GK given 1.2 as given in the table that is given in the questions. 1.2 GK ground floor multiply Lx 2 meters divided by half, where you get 0.5. That leads to you 1.2 kilonewton per meter. You will do the same process for the QK, which is given 2.5, and then for the roof, GK and QK. Again, you will do the same for slab BC. Since this question is only asking about frame B1 to 4, that means all the surrounding slabs are one-way slab. The calculation step is relatively simple. In the case that you need to calculate the load acting onto this beam and this beam, where it involves two-way slabs, then your calculations will have to refer to the table 3.15 of British Standard at 110. You will need to first get the shear force coefficients and then substitute into the equations. The beta here, it will be the shear coefficients. The N represent the design load, and Lx represent the shorter span length. Be careful with the type of the slab. Then you can compute the UDL acting onto the beams adjacent to the two-way slabs. Now let us proceed with our question here. As you have obtained the GK and QK for each slabs, Now you need to determine the UDL adding onto the beam. We still need to separate the calculations for the GK and QK. The reason being here, it will be we need to apply the factor of safety separately. The GK of the beams is determined from the GK of the slab AB plus the slab BC. That means 1.2 here plus 1.2. As for the QK, it will be 2.5 plus 2.5. And then do the same for the first floor and the roof floor. Having the GK and QK determined, now you will need to determine the maximum and the minimum UDL. Maximum UDL, you will have both GK and QK present. 1.35 times GK plus 1.5 times 5. Do the same for the first floor and the roof floor. As for the minimum UDL, only GK is present. 1.35 times GK, you will get the minimum UDL. Do the same for the roof floor and the first floor. Having these GKs and QKs determined, now you can calculate the critical load arrangement based on the GKs and QKs calculated, as well as based on the critical load arrangement that we have identified in the sub-questions A.